Hi guys, Erin here. Here's our second video about within subjects designs. In this video, you'll learn about some of the disadvantages and some possible solutions to those disadvantages. And then finally, very briefly, what statistical tests we use to test for condition differences when we are using a within subjects design. So one of the goals of what you should learn from this week and from the content from this week and last week is to be able to identify when you want to choose when to use within subjects versus between subjects design. And to answer this question, you really got to think of what are the pros and cons of each of the design and which pro you want to really take advantage of and which disadvantage is something that you just can't avoid. Because the advantages of one are essentially the disadvantages of the other. So there are three main factors that differentiate those two designs. First of all, the number of participants. As I mentioned in the last video, we need less participants for within subjects design. The extent to which individual differences can be a potential confound or make it difficult for you to see difference between conditions. This again is a problem for between subjects design and is better for within subjects design. The one factor that really is what makes a within subjects design not as great as a between subjects design are factors associated with time or with order of conditions that could impact a participant's response. So any experience that they have from one condition that might carry over and influence how they respond in the other condition is a potential confound that only exists really in within subjects designs when people are experiencing those multiple different conditions. It's not a problem for between subjects design because different people are receiving those different conditions, and so it's less likely that they're going to be impacted by those other conditions. So let's talk about some of the confounds that exist within subjects designs and what we can do to avoid them. The first one is a confound coming from possible environmental factors. And we talked about this last week as well. It's a problem for between subjects design as well. And we want to do whatever we can to identify these potential confounds and get rid of them. So these are characteristics of the environment that might differ or change from one treatment condition to another. So if we use the example from that taste test in the last video that I gave you when we wanted to see whether people prefer Pepsi versus Coke, well, if we always gave people Pepsi in a clean cup and we gave people Coke in a dirty cup, well, first of all, that would be disgusting. And second of all, we would have no way of knowing whether people prefer the Pepsi because they like the taste of it or whether they just like to drink out of a clean cup. So we want to avoid this confound due to the environment. And we can do this by holding those potential variables constant. So we can only test people using a clean cup, for example. We can match them across conditions. So we'd have an equal number of dirty cups given to people when they're trying Pepsi versus when they're trying Coke. Or we can randomize whether Pepsi is getting poured into a dirty or a clean cup. We want to make sure, regardless of whether we have different people getting our different conditions or if the same group of people are having the different conditions, we want to make sure that the only thing that differs between the conditions is our independent variable and that there's no other confounding effect that is unrelated to that independent variable that could potentially explain people's outcome and their scores on the dependent variable. The second major category of confounds is unique to within subjects designs and comes from the fact that we have the same participants experiencing our different conditions. And then we test them on the dependent variable after they've experienced all those different conditions. So an example of this might be and the confound is if their experience from one condition somehow carries over and impacts their performance when experiencing the other condition. We wouldn't know whether differences between groups on the dependent variable was due to the differences between conditions or possible carryover from experiencing those other conditions. So a good example of this might be, suppose we were interested in whether listening to calm music improves your test performance. So let's say we actually did this experiment and we had you guys, when you're doing your quiz, try 3 different versions of a quiz in 3 different conditions. Maybe we'd have one condition where you're listening to calm music, another condition where you're listening to really loud music, and another condition where there's no music. And you'd experience all those 3 different conditions, and you would take a test during those different conditions, and we'd look to see whether your quiz performance differed as a function of which condition you received. So there's potential for confounding variables that due to the fact that that are not due to what you received in those different conditions, the kind of music you're listening to, but is instead related to the fact that you're tested on multiple different conditions over time. And between the first time you're tested and the last time you're tested, you might be influenced by other factors that have nothing to do with the kind of music that you listen to. They could be due to time themselves. You know, if we test your performance on quiet music on a Monday and your performance when you're listening to loud music on a Friday, well, your scores on a Monday might just be crappy because it's a Monday and nobody likes Mondays, and your scores on Friday might be better because you know, you're just feeling good on a Friday. And so this could be a potential confound because we wouldn't know whether it was the music you're listening to or the time that you were tested. So also things might change throughout the course of the week. You might learn more throughout the week, and this could impact your scores and have nothing to do with the kind of music you're listening to. This confound from time itself is especially a problem when we're testing kids because they change so much in a short period of time. Another potential confound can happen when we test people multiple times and they get better at doing quizzes over time because they've got practice doing quizzes, or maybe they get worse at doing quizzes, especially if I tested you on 3 different versions of quiz 8 on the same day. Well, you might get so bored and so tired from staring at your screen and doing these quizzes all day that your performance on the last quiz that I give you might be worse than your performance on the first quiz I give you. And that has nothing to do with what music you're listening to. It was just about the order that you received it. So practice or fatigue effects or any learning that's happening between your different conditions, this could be a confound because we wouldn't know whether, like I said, it's your performance from listening to music or the learning and the carryover from the different conditions. Finally, previous measurements could also be a possible confound if the test itself, if it's a physical test and it starts to get ripped over time, or because of regression to the mean, which I'll explain in a second. So all of these factors are unique to within subjects design when we're testing the same group of people multiple times. So this slide might be a good chance for you to review some of these different time-related threats to internal validity. A good exercise might be for you to match these terms with their definition. Try to see if you can give an example on your own and try to see why, if you can explain why they are a threat to internal validity. I'm going to explain in a little bit more detail regression to the mean because I think maybe that is a little bit more fuzzy and doesn't really maybe is a little unclear. This is the phenomenon by which if scores are extreme on the first time they're measured, they'll tend to be more like the group average the second time they're measured. This is a visual that sort of shows this. If the red line is the average and people's scores tend to oscillate around the average, people who are really scoring high or really low on one measurement, on the second time you measure them are just going to tend to be more towards the average the next time you measure them. So let's use your quiz marks as an example. Your score on any given quiz is a combination of how much you know and how good you are at taking quizzes, but also a little bit of luck, and especially given we're using multiple choice questions. So for people who scored really, really high on, let's say, one version of a quiz, or people who score really, really low on that version of the quiz, chances are luck played a bit of a role at pushing those people to the very top or to the very bottom. If we all did 2 different versions of the same quiz, chances are that luck wouldn't play the exact same role. And people who perform really, really well on version 1 would perform a little bit worse on version 2, and people who perform really, really poorly on version 1 maybe would perform a little bit worse on version 2. This is the idea of regression to the mean. If we test people multiple times, people who score really extreme are going to tend to be more like the group average the next time we test them. And this could be a problem, a confound, if we find that there is a difference between people in when they're tested first versus second. That overall difference might be because there's true condition difference, but it might also be due to regression to the mean, and it's important for researchers to think about that and keep that in mind. Let's explain order effects in a little bit more detail now. So whenever participants are tested in a series of treatment conditions, they're going to gain experience in one treatment, and that could potentially impact their scores on the other treatment condition. And this could be because they get better, they have practice effects, they get better at taking a quiz, let's say, they maybe could get bored, or they could learn something from one condition that would carry over to the other. A good example of this last carryover effect is what we've talked about last week. So if we were interested in studying whether music training has an effect on and improves kids' math scores, we could really only do a between subjects design here, because if somebody is really learning a lot from music and that is impacting their ability to learn math, then you can't unlearn what you've learned in one condition. If you have music first, then that's going to impact also how well you learn art, and it's going to impact your math scores after you do the art condition. So there are 3 general strategies for dealing with these time-related and order-related threats to internal validity. The first one is that we maybe just can't use a within subjects design. And this is probably the solution for any kind of study that's looking at long-term learning effects or looking at intervention. Anytime people are learning something from a condition, they're going to forever be changed. And so when you test the next condition, it's going to be impacted by what they learned in the first condition. So in this example of studying to see whether music impacts children's math performance, you can't do it within subjects design. You can only do it between subjects design. Between subjects designs are going to be your best choice whenever order effects are going to be too big of an issue that you can't unlearn something, for example. The other 2 ways of dealing with it allow you to still use a within subjects design. What you can do is control time. I mean, you can't go back in time, but you can control the spacing between the amount of time between people get, the amount of time that exists between when people get their different conditions. So if you are testing, let's say, multiple versions of a quiz, you want to give people a break between their conditions. If you remember that example of the tasting test challenge between Pepsi and Coke, we would want to give people a little bit of break between tasting the Pepsi and tasting the Coke so that their taste buds are, reset and not influenced by what they just had before. But how much time you have between conditions is a bit of a trade-off. You don't want to increase it too much, or you're going to risk the chance that people are going to change over time, but you don't want to have it too short because you don't want to have those fatigue or practice effects carrying over. So you want to read other studies that have been done that are similar to what you're proposing for your research proposal. If you do a within subjects design, see whether they had people have a break between conditions and how long that break was, and you want to follow maybe what's been done before. The final solution, and this is one that you'll probably read about a lot if you're reading studies that do within subjects design, is counterbalancing between conditions. So this means you're alternating the order in which people receive their different conditions. So if we take our example of our Coke versus Pepsi challenge, and we have everybody trying Coke and Pepsi, we want to alternate what they get first. So half of the participants maybe will test Pepsi first and half will get Coke first, versus the other half will get Coke first and then get Pepsi. The balance, the benefit here is that we're eliminating the potential that it's the order of conditions that is impacting how people respond. So it might just be that people like Pepsi because it's the last thing they tasted. So you want to make sure that Pepsi isn't always the last thing that they taste, and at least half of your participants are going to taste Pepsi last and taste Coke last. So this eliminates the confound and of order effects. It doesn't totally get rid of the order effects. What it does is it spreads it evenly across your condition so that it's no longer a threat to internal validity. What do I mean by the fact that order effects still exist and that counterbalancing doesn't eliminate them? What am I talking about? I'm going to give you another example. Hopefully I'm not confusing you with all of these examples. In this one, we're actually going to use some numbers and we're going to show how the order at which you do different conditions can impact your result, can impact your performance on the dependent variable, and how counterbalancing can eliminate the confound but doesn't totally get rid of its effect. So let's use this as an example. Imagine you're interested in studying people's memory for words, and you want to know in particular whether the kind of words matter. You want to know whether people's memory for positive words is better than their memory for negative words. So you have participants read lists of positive words like happy, joyful, smiling, love, friends, and then we test their memory. And then we have them read lists of negative words like murder, blood, gore, angry, victim, all sorts of negative words. And then we test their memory after reading those words. So we're going to get an average memory score for the positive words, an average memory score for the negative words, and we want to see whether there's a difference between these two conditions. We want to use a within subjects design because people's memory is going to differ in general, regardless of what kind of words they have. And this will create a lot of individual differences that could potentially be a confound and could potentially wash out and make it difficult for us to see whether there's a difference in between people's memory for positive versus negative words. So we want to do a within subjects design in this case because individual differences, could be a problem. In this example, let's start off by showing what this would look like if we don't have order effects, we haven't done counterbalancing, and then I'll show you what it might look like if there are order effects and how counterbalancing can affect this. So here's some data that maybe we'd get from this fictitious experiment. So it's a within subjects design, so we list all of our participants here, and we've listed now their performance, the percentage of words that they get correct when they are reading positive words compared to when they're reading negative words. So you can see that there's some variation among people. This person's memory is pretty bad, but because we're testing them, the same people in the two different conditions, it doesn't really matter because their performance is going to be bad in both of the conditions. We're going to be able to see whether there's a difference between the conditions. So in this example, we take an average then for all of the people when they are reading the positive words, what their memory for those words are, what their memory for those negative words are, and we do some stats. We do a paired t-test to see if there's a difference between our two conditions, and we find that this number is bigger than 0.05, so our conclusion would be that there is no significant difference in people's memory. They remember the same number of words regardless of whether they're negative or whether they're positive. All right, now let's imagine you were actually a participant in this experiment and you have to read and memorize long lists of positive words and then long lists of negative words. This sounds like a pretty boring experiment. And imagine there's no break. You've got to do this for like an hour. You're just reading and memorizing words. And it's always the case that the positive words are presented first and the negative words are presented second. Well, our confound here is that we've got order effects that are affecting one of the levels of our independent variable more than the other. The negative words are always happening second. So if there's no break, people are going to get tired and they're going to get bored. Their performance for the negative words is going to get worse. The negative words is always happening after the positive words, so we could get some interference where their memory is just getting worse because they've been reading so many words. In any case, it's going to affect our one condition more than the other. So we have a confound here. Let's look and see how this would affect our data. So here we have our participants. Where's my arrow? Here it is right here. Our participants. Here's their memory for positive words, percent correct. This is the data that I had showed you before, and I've just changed it a little bit to show that there is this fatigue effect. So I've just subtracted their score a little bit. I've taken 6 randomly. I picked 6. Took 6 away, so it's smaller. So you can see here that that consistently fatigue and getting bored in this experiment is really causing people to perform worse only in this condition. And if we actually did this experiment and where these order effects really exist and they're a problem, we'd find that the group average or the condition average for this would be quite different. So this is the average that I showed you before if there were no fatigue effects, and here's the average now when there are fatigue effects. It's much lower. And if we did some stats and looked to see if that difference was meaningful, we'd see this would be the value we get for our p-value, and we'd say, oh, it's less than 0.05. There's a significant difference between conditions. And so the conclusion we would draw from this is that people's memory is worse when they read negative words compared to positive words. And you can imagine a study actually saying this, you know, when you read, and that you can come up with all kinds of explanations of why this might be. You know, we try to like avoid negative words. They make us feel bad, and so our memory is worse for negative words compared to positive words, when in fact this would totally be BS, because we have this confound of order effects only affecting our negative words. So this is a confound. This is going to limit the internal validity of our study, because the fatigue effect is only affecting one condition, not the other. And this could potentially interfere with our ability to draw really true conclusions from this study. So what's a good solution? Well, maybe we want to try counterbalancing. So counterbalancing means that we control the order of conditions so that some people get one condition first and the other condition second. So participant 1 gets the positive words first and the negative words second. Participant 2 gets the negative words first and the positive words second. I'm going to show you how fatigue effects are still going to exist, but by counterbalancing, we're at least making sure that they don't just affect one condition and not the other. Okay, let me show you. So here's our participants. Here's the order they get. This is the scores I just showed you before. And I've put an X through to say we're going to change them a little bit depending on the order that they receive. So imagine that people are getting bored throughout their experiment, and whatever condition they get second, they're going to perform worse than the condition they got first. So this person got positive words first, so that one's not affected by order effects, but they got the negative words second, so that condition's going to be affected by order effects. This person got negative words first, so their negative words are going to be relatively high, but their positive words they got second, and so that's going to go down. So you can see how across participants, the order effect is going to impact whatever condition they get second. But because we've evenly distributed which condition comes first and comes second, that effect of fatigue and boredom is going to make sure that it's no longer a confound in our experiment. So if we did our stats, we would come up with that same conclusion we had at the beginning when there weren't any order effects at all, when maybe they had a break and they made sure people actually were engaged in the experiment. And our conclusion then would still be valid, would be like what we had before, that there is no significant difference. It doesn't matter what kind of words you're reading, your memory is going to be the same. So counterbalancing spreads out the order effects across condition. This increases the internal validity because we know now it's not systematically affecting one condition and not the other, but it doesn't totally eliminate it. Those order effects, the fact that people are getting bored and their performance is going down just because they're getting tired, this is still going to impact the average. So those order effects are still affecting some people's performance. So it's best to try to, give people breaks and make sure that they're not getting tired and that that's not impacting their results. Another limitation of counterbalancing is that when you've got lots of conditions and you want to try to make sure that every possible order of conditions is presented, that's going to make it really hard to do when you've got lots of different conditions. And another limitation is if one condition tends to have if fatigue affects one condition more than the other, then counterbalancing is not going to totally get rid of it. So there's some limitations to counterbalancing. It's not going to solve all of your problems, but whenever you do a within subjects design, you should still consider it because it's going to at least increase the internal validity of your study. So if you have to decide for your research proposal whether to do a within subjects design or a between subjects design, you want to consider the pros and cons of both and try to ask yourself these questions and decide which is the best study for you. Is it difficult or costly to recruit test participants? If yes is the answer, if you're wanting to test a specific kind of clinical population, then you may want to do a within subjects design because it's harder to recruit lots of participants. Do you expect that there'll be lots of individual differences in your study that could potentially distort your findings? If yes is the answer, then you want to do a within subjects design. You don't want those individual differences to make it so you can't see and report a significant difference. If, on the other hand, you expect that time or order effects are going to distort your findings, then you want to do the reverse. You want to have a between subjects design and not a within subjects design. And then finally, if you think both of them are a problem, then you can do a match design. And I'm not going to go into detail about that here, but you can read about it in your textbook. So briefly, how do we test for group differences? It's quite similar to what we talked about last week with between subjects design, only there's special stats that we can do that can take into consideration that the same people are getting those different treatment conditions and that the variance is the same in the two different conditions. If we are comparing two different levels of our independent variable, then we can do a t-test. When we have a within subjects design, we use a repeated measures t-test. Versus when we have a between subjects design, we do an independent samples t-test. When we have more than two groups, we can't do a t-test, we have to use an ANOVA. And when we have within subjects design, we use a repeated measures ANOVA. And you can read about the pros and cons of having more than two groups in your textbook. I thought I would finally end this by giving you an example of some of the research that I do. In my research, I study the brain networks that people use to understand language. In my research, I use a within subjects design because individual differences is too much of a problem. What I want to do in my research is compare how people process language, and I want to look to see how they process, the meaning of language, the grammar of language. So I present people with two different conditions. I'll give them maybe correct sentences and sentences with a subtle mistake. For example, maybe they'll listen to sentences like he put the cup on the table versus he put the cloud on the table. And I study their brain response in response to words that make sense versus that don't make sense in the sentence. And the logic here is that we'll get extra brain activity for words that don't make sense, and this will occur in areas of the brain that are important, in this case for processing the meaning of speech. And I have to use a within subjects design because if I did a between subjects design, there'd be way too many individual differences in terms of which part of the brain people use and how well they recruit it. So I avoid some of those problems by comparing the same group of people while they listen to different kinds of sentences. And if you're interested in learning more about this, if this interests you at all, feel free to send me an email because we'd love to have new research assistants. Or maybe it's a project you'd like to be involved in for your fourth year thesis. So to briefly summarize, a within subjects design uses one group of participants and gets multiple different kinds of treatment, gets your multiple treatment conditions. There's some pros and cons. We've talked about how to deal with them. Deciding whether to use a within subject or between subjects design, you really got to consider the number of participants, individual differences, and time and order effects, and decide which of these is going to be the most problematic, and then you want to use the one that avoids that problem. The kind of statistical tests you use will depend on the kind of data that you have and the number of conditions that you have. That's all for this week, and we'll see you at our next Teams meeting. Have a good day.